Wake up, Paul.
Hello? What is that?
Psst. Hey, down here. Yeah, you. Down here in the microscope. Hi, Paul.
Oh! Where's your magic bus?
I left it at home. I couldn't fit all the enzymes in it.
What enzyme?
The enzymes for replication, silly.
That's right, Miss Frizzie. DNA replication requires many enzymes. First, however, you should understand the structure of DNA. DNA nucleotides are represented by blue, pink, green, and white blocks. DNA primers are represented by yellow blocks. When DNA replicates, the leading strand is synthesized continuously from the 5' to 3' end.
Remember to always synthesize DNA from the 5' to 3' end. Now, let's take a look at the enzymes that make replication possible. This is helicase.
Helicase unwinds the original double helix at the replication fork. Another enzyme called topoisomerase releases the tension caused by this unwinding.
Let's meet primase.
In order for replication to begin, primase must synthesize an RNA primer at the 5' end of the leading strand. Only then can DNA polymerase III begin to add nucleotides.
Here's DNA polymerase I and DNA polymerase III.
Using the original strand of DNA as a template, DNA polymerase III synthesizes a new DNA strand by adding nucleotides to the 3' end of the pre-existing DNA strand or RNA primer. DNA polymerase I replaces the RNA primer with DNA nucleotides.
Remember to always synthesize in the opposite direction of the original strand. Now let's meet ligase.
Ligase joins the 3' end of DNA that replaces the primer to the rest of the leading strand.
Now let's examine the other strand, called the lagging strand. Unlike the leading strand, the lagging strand is synthesized discontinuously. This is because DNA polymerase can only add nucleotides to the 3' end. The lagging strand grows 3' to 5' overall by the addition of Okazaki fragments that grow 5' to 3'. Welcome back, primase and DNA polymerase III.
Primase synthesizes an RNA primer at the 5' end of each Okazaki fragment. DNA polymerase adds the bases that form the Okazaki fragment. Okazaki fragments keep replication moving towards the expanding replication fork, even when the template DNA strand replicates in the 5' to 3' direction.
Here's DNA polymerase I and ligase again.
DNA polymerase I removes the RNA primer from the 5' end and replaces it with DNA nucleotides. Ligase joins the Okazaki fragments.
So Paul, do you understand replication now?
Yes, thank you, Miss Frizzie.
Now go ace your test, and on Wisconsin.
Frizzie!